Welcome back. Jump Game 2. What are people saying about this? We go to solutions. There's a mix in the comment section. People like it, people don't like it. People said that it doesn't work. We're gonna make sure that our problem actually does work. So let's jump into Jump Game 2. You're given a zero index array of integers num of length n, and you are initially positioned at num0. Nums this, nums that. What does that mean? Well, we're gonna find out if chat can make this sound better. Plug that in, have chat read this to us, see if it can make more sense than what we just saw.
Problem summary. You are given an array nums, where each element represents the maximum jump length from that position. Starting at index 0, determine the minimum number of jumps required to reach the last index. It's guaranteed that the last index can always be reached. Anime story The Hero's Final Leap. In the vibrant city of Astra, a young ninja named Riku trained tirelessly under the watchful eyes of his master. This wasn't just any ordinary training. He was preparing for the Jump Trials, an ancient competition that only the fastest and smartest could conquer. The goal? To leap across a series of magical platforms, each with varying energy boosts, and reach the final glowing crystal. Each platform's boost was marked with an energy rune. The higher the rune number, the further Riku could jump. However, Riku needed to conserve his energy and make as few jumps as possible to win the title of Champion of Astra. The glowing crystal at the end shimmered brightly. With every leap, Riku's mind raced. How can I minimize my jumps and still reach the end? It was now or never. Riku tightened his headband, focused on the runes ahead, and began his calculated journey. Here's how Riku's strategy translates into a Java solution. Java public class solution, public int jump int platforms, int jumps equals 0. Number of jumps Riku has made, int current end equals 0. The farthest Riku can reach with the current jump, int farthest equals 0. The farthest Riku can reach overall, traverse all platforms except the last one, for int I equals 0, I platforms.length-1, I plus, farthest equals math max farthest, I plus platforms I. If Riku reaches the end of his current jump, if I equal current end, jumps plus plus. Current end equals farthest. Update to the farthest position he can now reach. Return jumps. Minimum number of jumps needed. Explanation of the code. 1. Jumps counter tracks the number of jumps Riku makes. 2. Current end represents the end of the range Riku can currently reach with the current jump. 3. Farthest calculates the farthest platform Riku can jump to at any moment. 4. Logic loop through the platforms, excluding the last one. Update the farthest Riku can jump. If Riku reaches the end of his current jump, increment the jump counter and update current end. This ensures Riku makes the minimum number of jumps to reach the glowing crystal at the last platform.
I do want to create a thumbnail, and I've been excited with all these thumbnails and see what it comes up with. While it's doing that, we're going to copy the code so we are able to see if it works. This part always gets me nervous. Wow, that is clean. That is clean. It has a little Naruto band. That is pretty dope. Pretty dope. I'm sorry it didn't work, Mazur, but hopefully this one right here works. Go into here and plug this code in. Everything should work perfect. Case 1 and case 2 have passed. Submit that. Our next question will be H index. It's a little ambiguous. It's a little weird title. All right, see you in the next one.